Hey Math 1, this is part 2 of section 1.9, notes. So the second example on the notes is given up here. Looks like we've got some grouping symbols. So hopefully that's sort of like your telltale sign that the distributive property will be enacted on this very first step. We can't do anything inside the parentheses because x and 7y are unlike terms. You can't add them, nor can you subtract them. 7x and 8y, we can't do anything until we multiply by that outside number. So you take 2 times x, and that gives you 2x. You take 2 times 7y, you get positive 14y. Now you go to the next group. Negative 3 gets multiplied by the 7x, which is negative 21x. And then you take negative 3 times negative 8y. Well, this is going to be the thing that oftentimes will hurt students. A negative times a negative is a positive. 24y. So to go from here to here, you used the distributive property. By the way, I'm okay with you writing that right here. I'm running out of room, so I'm just using my surroundings the best I can. Next move. I need the like terms to be side by side. So which of these properties rearranges the terms so that the like terms are side by side? Switching the order of addition to get the like terms side by side. Commutative property. So plus 14y is going to switch spots with negative 21x. Okay, so 2x isn't changing. Plus 14y and negative 21x are switching. So you got a negative 21x there, and now a plus 14y here. Plus 24y just kind of moves down like it didn't move at all. On this move, you employ the commutative property. By the way, you can keep pointing it to the right as well if this seems like too distracting, all over the place, not organized. Yeah. Okay, now compute. 2 minus 21 is negative 19x. (14 plus 24 is 38y. And you're done. Just make sure you justify that the property that gives you the basic calculations here is substitution property. Substitution prop. All right. So I hope you guys are thinking like this is a less rigorous proof writing process than the order of operations was. Let's try another one over here. Let's see, do we get everything in the one shot? Pretty much. All right. There's a lot more going on here. The first thing that I need to explain is what are we supposed to do when it's 7 minus, and there's no number in front of the grouping symbol. There's no number that's being multiplied by the parentheses. The same thing's happening over here. It's just plus parentheses 3y minus 9x. Well, here's one trick that people have come up with. They say, well, you know how when you're dealing with an x, like if I said x plus 5x, someone's like, hey, that actually has a coefficient. It's 1x. Oh, that makes sense now. 1x plus 5x is 6x. Okay, if you use that idea, what you can do is put sort of like this placeholder 1 in front of there and a placeholder 1 in front of here too. Just to remind yourself that, hey, I am distributing something through. I'm distributing either a positive 1 to the second group or a negative 1 to the first group. And then you go for it. So the 7 has to just be patient on this first step. The 7 is not being, subtraction does not come before multiplication in the order of operations. Everything inside this group now is going to be multiplied by -1. So -1 times 5x is minus 5x. -1 times 3y is minus 3y. -1 times negative 7xy, a negative times a negative, is positive 7xy. In this group, you take a positive 1 times 3y. Multiplying by 1 changes nothing. It's still a positive 3y. Taking a positive 1 times a negative 9x, nothing changes. It's still a negative 9x. And this minus 13xy is still chilling in the background. This is the distributive property step. All right, now hopefully you guys are seeing that there's a clear cadence in which these problems go. If you've got grouping symbols, it stands to reason you're going to use the distributive property. Then you must get the like terms side by side. I'm going to go with the xy's first. You don't have to go with the xy's first. I'm just going with them first. So a plus 7xy could be moved all the way to the front. A minus 13xy can be moved all the way side by side with it. All right? I got my 13xy and my negative 13xy and my 7xy side by side. Let's go with the minus 3y put side by side with plus 3y. We'll go negative 5x being moved side by side with negative 9x. And then there's just a positive 7 left over at the end. Yeah, that's the commutative property. Rearranging things so that the like terms are side by side. Now we compute. 7 minus 13 is negative 6xy. So this is gone. Oh, I'm sorry. I forgot to put the plus 3y here. My apologies. After so many hours in a day, you're going to start making mistakes, right? So the negative 3y here and the positive 3y here are side by side. Negative 3 plus 3 is 0y. But we had the multiplicative property of 0 that said 0 times anything is 0. So what I'm going to do is, when it becomes 0y, I'm just going to cancel it out, and it's gone. There's no y term represented now. All right, negative 5 minus 9 is negative 14x. Yeah, and then plus 7. And that's a substitution property. All right, I've got one more example where you have to generate a proof from scratch. This one's a little scary. It's got decimals. But that's okay, you can do it. All right, so this just gives you guys some extra practice with what am I supposed to do when I multiply decimals and then have to add or subtract them as well. So you see the grouping symbols. Hopefully it's clear that distributive property has to happen to get rid of them. So you're going to do 2.6 times 3.5x to start with. So now we got to be really careful because you can't do a lot of that math in your head. So you're going to have to say, this is my first step. I have to take 2.6 times 3.5x, so I'm going to do that calculation off to the side. I would say this is off to the side for me. All right, so we got to remember some things. And I'm just going to include the x at the end. I don't have to actually deal with it with this calculation. So 5 times 6 is 30. Carry the 3. 5 times 2 is 10, plus 3 is 13. Drop a 0. 3 times 6 is 18. Carry a 1. 3 times 2 is 6, plus 1 is 7. Add the columns, 0, 11, 7, 8, 9. 1, 2 decimal places represented to the right. So you're going to go 2 decimal places in. And here's the thing. When it ends in a 0, you can just say, hey, instead of putting 9.10, I'm going to put 9.1. So it's 9.1x. Calculation number 1 done. Calculation number 2. Take 2.6 times negative 4.2y. So here's my first calculation. Here's my second calculation. I dropped the negative just because, I really just have to figure with the digits here. We know it's going to be minus, and there's going to be a y on the end of it. That's 12. 2 times 2 is 4 with a 5. Drop a 0, multiply 24, carry a 2. 8 plus 2 is 10. So 2, 9, 0, 1. 2 digits are represented right of the decimal, so 2 digits in. It'll be 10.92y. Subtraction is happening there. Okay, good decimal multiplication review. It's always good to keep that skill intact. Now, because there's just a minus right here, you can infer that there's a negative 1. So you could just multiply a negative through, which makes positive 13.1 negative 13.1x. Negative 1 times positive 6y is negative 6y. So, excuse me. That makes the first distributive property step complete. Step 2, we need to get the like terms side by side. That's the commutative property. So this 9.1x and this negative 13.1x need to be together. So I'm just going to flip-flop these two terms. The negative 13.1x goes here. The negative 10.92y goes here. And then the negative 6y remains. All right, and then we got to keep track of how to not multiply decimals, how to add or subtract them. So, when you look at 9.1x minus 13.1x, you have to keep in mind that when you try to find the difference between two numbers, you have to put the bigger number on top if you stack them. And with decimals, you got to stack the decimals. So, you're going to do 13.1 minus 9.1 with the understanding that because you're taking away a bigger number initially, that this number is just going to be negative. Here's what happens if you... Okay, so here's how you do that. 0, 4. It's 4. It's negative 4.0x. I'm just going to call it negative 4x. Here's what happens if you put the 9.1 on top. I've seen a lot of students do this. 0, 9 minus 3 is 6. That's a 1 that's just there, and they put a negative out front. Or they'll leave it positive. That really makes no sense at all. You're saying the difference between 9 point something and 13 point something is 16. So just make sure you're using good logic there. Put the bigger number on top every time you're subtracting, and you shouldn't get in trouble with that. Last calculation. Negative 10.92 minus 6. Okay, so negative 10.2 minus 6. If you see a negative number that is subtracting something, you are moving further left on the number line, which means you are taking the digits 10.92 and adding it to 6. And you got to make sure you're lining up those decimals. So decimal addition, subtraction, and multiplication are actually pretty complicated. And there's a lot of rules to keep into play. Just make sure you know that basic thing. It's negative, and you're taking away, which means it's more negative now. So you add the digits together. It's negative 16.92y. That, of course, was the substitution step. These don't need to be referred to inside the problem. You just need to show that you're doing the calculations and you're not just blindly punching numbers into a calculator. Prove that you know how to do this so that you can move on to the next stuff we're tasked with. So that's the subprop, and we're done with that proof. All right. Sorry, this has ended up being a longer video than I wanted it to. I do want to make sure I show you the very last part to this. So much like yesterday, I showed you guys how to fill in a proof. That's already been done for you. They did all the calculations. Your job is just to name what's happening from one line to the next. So when you see this first group right here, it had grouping symbols, and now it doesn't have grouping symbols. It multiplied negative 2 times the parts here, and it multiplied negative 7 times the parts here. That's the distributive property. From here to here, it looks like there's as many terms as existed before. So we didn't simplify anything. There's no substitution method there because we didn't calculate anything to make a smaller, like 2x's didn't become 1x. In fact, all we did was we flipped around. The 21y came all the way to the 6y. The negative 14x went side by side with the negative 2x, and the negative 2xy moved to the back of the line. That's the commutative property. We rearrange things. Here is where we went from 6y plus 21x down to 27y. We went from negative 2x minus 14x down to negative 16x. That is the justification for basic calculations substitution property. Now that's usually the final statement. What the heck is going on here? Well, it looks like they just decided to move the negative 16x over here and flipped it with the 27y. Now, it doesn't seem to create any kind of calculation beyond that. They just rearranged it. Well, you can do that. The commutative property says you can. All right, so that was kind of a tricky last move. All right, my apologies for the lengthiness of this video. Thank you for being patient, and I hope you guys found this helpful. It helped you with the homework, and you enjoyed it. Maybe. All right, thanks for watching.